Good morning, third grade. Our target for today is I will be able to accurately add multiple numbers. We're going to start with some vocabulary that you'll need to know for today's lesson. The first word is addend. Addends are the parts in an addition equation, the numbers that you are adding. Look at the example, 16 plus 4 equals 20. In the problem, 16 plus 4 equals 20. 16 is an addend. 4 is also an addend. 16 and 4 are addends because they are the parts in this equation. Another word you'll need to know is multiple. Multiple means more than one. Take a look at that picture of the bush. That bush has more than one flower. So we would say that bush has multiple flowers. Multiple means more than one. You'll also need to know two properties of addition. We're going to start with the commutative property of addition. The commutative property of addition tells you that you can add numbers in any order without changing the sum or answer. Take a look at our example. 3 plus 7 equals 10. 7 plus 3 also equals 10. It does not matter what order you put the addends in. It does not change the sum or answer. The commutative property of addition tells us that we can rearrange the parts or addends without changing the sum. We're also going to talk about the associative property of addition. The associative property of addition tells us that you can group addends in any way without changing the sum or answer. Take a look at our examples. You can see that we're adding the numbers 8, 2, and 1. In the first example, we did not group any of the numbers. We just added all three of them, 8, 2, and 1. However, the additive property of addition tells us that we can go ahead and group the numbers in any way. Since we know that 8 and 2 make a 10, we will group those together. We'll group the 8 and the 2 to make a 10 and then add the 1. 10 plus 1 is 11. We can group those addends, 8 and 2, together to make the 10 because the associative property of addition tells us that we can group the addends without changing the sum. Sometimes, third grade, you're going to need to add more than just two numbers at a time to solve a problem. When we have to add more than two numbers at a time, we call this adding multiple addends. In our real life, we have to add multiple addends all the time. Take a look at these pictures. You can see that I have 6 gummy bears, 6 lollipops, and 4 Starbursts. If I wanted to know how much total candy I had, I would need to add the 6 gummy bears plus the 6 lollipops plus the 4 Starbursts. I would need to add multiple addends. Today, you're going to learn two different strategies for adding multiple addends. There are two different ways you can do it using our associative and commutative properties. Both of them work. It just depends on what's easier for you. Let's go ahead and think about that exact problem. 6 plus 6 plus 4. When you need to add more than two numbers, there are two different strategies you could use. The first strategy you could use to add more than two numbers is to add all of the numbers at once. Here you can see I've taken that problem, 6 plus 6 plus 4, and I've written it vertically. We're going to add all of the numbers at once, just as though we were adding only two numbers, except now there are 3. We're still going to make 10s. We're still going to regroup. It'll be just like adding two numbers, except now we have 3 numbers to keep track of. Look at the numbers 6 plus 6 plus 4. I notice right away that there's an easy 10. So I'll go ahead and group one of the 6's and the 4 together to make a 10. 6 plus 4 makes a 10. So I'll regroup that 1 10 to the tens place. After I regroup that 1 10 to the tens place, I can see that I have just 6 left in the ones place. 1 10 and 6 ones is 16. So 6 plus 6 plus 4 equals 16. For some kids, it's easy to add all of the numbers at once, just like we did. For some kids, adding all three numbers at once can be tricky. For some kids, they choose to use the second strategy, adding two numbers at a time. We still need to add the problem 6 plus 6 plus 4. Thankfully, the commutative property of addition tells us that we can add numbers in any order, and the associative property of addition tells us that we can group numbers in any order. I'm going to go ahead and start by adding 6 and 4, which are each addends in the problem 6 plus 6 plus 4. I've chosen to add 6 plus 4 first because I know that 6 and 4 make a 10. Mathematicians always use the most efficient strategy for them. They also choose to do the math that is most efficient. Since I know that 6 and 4 make a 10, I'll start by adding those because 10s are very easy. You can see up here in my original problem, 6 plus 6 plus 4, I have crossed out one of the 6's and one of the 4's. If you're choosing to add two numbers at a time, it is very important that you keep track of which numbers you've already added and which ones you still have left to add. That is a way that kids often make mistakes. They lose track of which numbers they've added and which numbers they haven't. So go ahead and make sure you're crossing them off as you go. Now that I've added 6 plus 4, which equals 10, the only addend I have left to add is 6. So I'll take the 10 from 6 plus 4, and I'll add my other addend, 6. Since now I'm adding that last addend, I'll go ahead and cross it off in the problem. 10 plus 6 is easy for me. I can add it in my head. 10 plus 6 equals 16. So the answer to my entire problem, 6 plus 4, is 16. You can see that it did not matter if I added this problem all at once or by adding two numbers at a time. My answer was the same. You can use either strategy when you are adding multiple addends. You can add all the numbers at once, or you can choose to add just two at a time. Let's go ahead and take a look at another problem. We'll solve this one together. Here's the problem 9 plus 8 plus 7. We're going to solve this problem together. I'm going to go ahead and solve this problem by adding all of the numbers at once. I'm going to write the problem vertically. 9 plus 8 plus 7. There's my problem written vertically. 9 plus 8 plus 7. Now, just as if I were adding two numbers, I know that I need to make a 10. I see that there's a 9 up here, and I see that there are no easy 10s. So I'm going to need to use my make a 10 strategy. I'll go ahead and decompose the 8. And I'm going to think to myself, what does 9 need to become a 10? 9 needs a 1. So I'll decompose the 8 into a 1 and a 7. I will group the 9 and the 1 to make a 10. Now I'm going to look at what I have left. I have 7 left from decomposing the 8, as well as another 7. I know that 7 plus 7 is going to be more than 10. So I'm actually going to need to make another 10. Sometimes, third grade, this happens when you're adding multiple addends. You may need to make more than one 10 in a place. I'm going to go ahead and decompose this 7, although I could decompose either one, into a 3 because 7 and 3 make 10, and 4 because 7 and 4, or 3 and 4 make 7. I'll group this 7 and this 3 to make a second 10. I see that all that I have left now is a 4, so I cannot make another 10. Now, third grade, this is critical. If you make more than one 10, you need to regroup more than one 10. We can see that I made 1, 2 10s. So I'm going to regroup 2 10s to the 10s place, not just one. If you make 2 10s, you need to regroup 2 10s. That's a mistake that third graders often make when adding multiple addends. If you make more than one 10, you need to regroup more than one 10. Now that we've regrouped our 2 10s to the 10s place, let's go ahead and look at what's left in the 1s place. Oh yes, there's just 4 left in the 1s place. Now we can look at our 10s place. We have the 2 10s that we regrouped. We can see that 9 plus 8 plus 7 equals 24. For some kids, adding all the numbers at once, like we just did, is the easiest strategy for them to use. For some kids, it's easier to add just 2 numbers at a time. Let's go ahead and look at another problem. Here's the problem 8 plus 6 plus 8. We'll go ahead and solve this problem by adding 2 numbers at a time. I'm looking at my numbers 8 plus 6 plus 8, and I'm not seeing any numbers that make a 10 or that are easier to add than others. So I'll go ahead and add 8 plus 6. I can see that this is going to equal more than 10, so I'll use my make a 10 strategy. 8 needs a 2 to become a 10, so I'll decompose the 6 into a 2 and a 4. 8 and 2 makes a 10, so I'll regroup that 10 to my tens place, and I can see that I have 4 left in the ones place. 1 10 and 4 ones is 14, so 8 plus 6 equals 14. You probably noticed, third grade, that as soon as I wrote down the 8 plus the 6, I crossed them out in my original problem, so that I would remember I've already added those numbers. Remember, when you're adding 2 numbers at a time, it is very important you keep track of which numbers you've added and which you haven't. I can see that I've added the 8 plus 6 and it equaled 14, but I can also see that I have another 8 left to add. So I'm going to take that 14, which was the same as 8 plus 6, and I'm going to do 14 plus 8, that number I have left to add. I'll now cross that 8 off because I've written it in an equation. I can see when I start in my ones place that 4 plus 8 will be more than 10. I'll decompose the 4 and I'll think, what does the 8 need to become a 10? Oh, that's right. The 8 needs a 2. Now we'll think about this 4. 2 is one part of 4. The other part of 4 is 2. So I'll decompose the 4 into a 2 and a 2. I'll make my 10 and then regroup it. And I'm going to think, what's left in the ones place? Oh yes, 2 is left in the ones place. Now look at the tens place. We have the 10 that we regrouped and the 10 that was already there from 14. How many 10s do we have total? Yes, 2 10s. So the answer to 14 plus 8 is 22. That is the answer to our entire problem, 8 plus 6 plus 8, because now that I've added all of the numbers, I found the answer, 22. For some kids, third grade, adding 2 numbers at a time is the best strategy because it's easier for them to keep track of just 2 numbers at a time. I want to show you, third grade, that sometimes we can add even more than 3 numbers. You can see here we have 4 numbers to add, 5 plus 8 plus 7 plus 2. We're going to go ahead and add 5 plus 8 plus 7 plus 2 all at once. 5 plus 8 plus 7 plus 2. Let's go ahead and add these all at once. I know that I'm going to need to make a 10 because 5 plus 8 plus 7 plus 2 will certainly equal more than 10. I'm going to start by thinking, are there any easy 10s? Are there any numbers I can easily group together? Oh yes, the 8 and the 2 is an easy 10. So I'm going to go ahead and make a 10 with the 8 and the 2. Now I can see that I've already made one 10 and I still have 5 plus 7 left. 5 plus 7 is going to be more than 10, so I'm going to make a 10 with 5 and 7. I'll think to myself, what does this 7 need to become a 10? 7 needs a 3, so I'm going to break apart my 5 into a 3 and another number. Now think about the parts of 5. 3 and what make a 5? Oh yes, 3 and 2 make a 5, so I'll decompose the 5 into a 3 and a 2. I'll go ahead and group the 7 and the 3 to make another 10. I want you to take a moment and think, how many 10s did we just make? Yes, we made 2 10s. The 8 and the 2 made a 10, and the 7 and the 3 made a 10. So I need to regroup 2 10s to the tens place. What do we have left in the ones place? You're right, we have 2 left in the ones place, and in the tens place we have the 2 we regrouped. 2 10s and 2 1s is 22, so 5 plus 8 plus 7 plus 2 equals 22. For some kids, adding all the numbers at once is easy. For some kids, it's a lot to keep track of, and even for me, when I look at this paper, I get a little bit confused because there's so many lines and numbers going on. For some kids, adding all the numbers at once is easy. For some kids, it's better to add 2 numbers at a time. Let's go ahead and add the problem 5 plus 9 plus 5 plus 3 just two numbers at a time. I want you to look at those numbers we're adding, 5 plus 9 plus 5 plus 3. Do you see any numbers that it would make sense to group together? Do you see any numbers that are easy to add? Oh, yes. I also noticed that there's a 5 and a 5 in this problem, so I'm going to start by adding the 5 and the 5. Remember, the associative and commutative properties tell us that we can add numbers in any order, and we can also group them in any order without changing the sum. So I can go ahead and start with the 5 and the 5, because I know as long as I add all the addends, the answer will be the same. 5 plus 5 is so easy for us. 5 plus 5 is an easy 10. So now I've added the 5 plus the 5. I have two more numbers left to add, 9 and 3. I'll go ahead and add the 9 plus the 3 now. 9 plus 3 is going to be more than 10, so I'll use my make a 10 strategy. What does 9 need to become a 10? Yes, 9 needs a 1, so I'll break apart the 3 into a 1 and what other number? You're right, 1 and 2 make a 3, so I'll decompose the 3 into a 1 and a 2. I'll go ahead and make my 10 and regroup it, and I can see that 9 plus 3 is 12. Now, third grade, we've added all the numbers in our equation, 5 plus 9 plus 5 plus 3, and now we have the numbers 10 and 12. We'll now add together 10 and 12 to find our final answer. 5 plus 5 was 10, 9 plus 3 is 12. We'll add those together to find our final answer. What is 10 plus 12? Yes, 10 plus 12 is 22. So 5 plus 9 plus 5 plus 3 equals 22. For some kids, adding the numbers two at a time is easier. For some kids, adding all the numbers at once is easier. Some kids use both. It just depends on the problem. You can solve multiple addend problems either by adding all the numbers at once or by adding two numbers at a time. We're going to go ahead, third grade, and look at a couple of mistakes. I want you to see if you can find the mistake that I've made here. Oops, let me fix this. You can see that I am adding the problem 9 plus 7 plus 9. You can see the work that I've done. Take a moment and think, what is the mistake that I made? If you need to pause the video to really look at this problem, that's fine. In fact, go ahead and pause the video and solve this problem on paper, adding all of the numbers at once. Then you'll be able to easily see what I did wrong, because you'll see what you did right. What is the mistake that I made when I added the numbers 9 plus 7 plus 9? I'm sure you noticed that when I was adding 9 plus 7 plus 9, I made two 10s. Now I made a 10 with a 9 and a 1, and I made another 10 with a 9 and another 1. I made two 10s in the ones place, but I only regrouped one 10. I should have regrouped two 10s because that's how many 10s I made. My answer would have then been 25 instead of 15. 25 is the correct answer. Let's go ahead and look at another problem. Here's a problem where I added the numbers 7 plus 8 plus 6 plus 7, just two numbers at a time. Take a look at the work that I did. See if you can find the mistake that I made. You're right, third grade. I forgot to add one of the numbers. I added 7 plus 8, which equaled 15. Then I took the 15 and I added 6 for an answer of 21. I forgot to add this other 7. So I would need to take the 21 and add 7 more. 21 plus 7 equals 28. So the correct final answer should have been 28. Now, third grade, it's your time to shine. On a piece of paper, I want you to write the problem 8 plus 7 plus 6 vertically. You're going to solve this by yourself. You may decide if you want to add all of the numbers at once or if you would rather add them two at a time. You will write it on a piece of paper and solve the problem. Then you may choose the correct answer to the problem 8 plus 7 plus 6. When you correctly add 8 plus 7 plus 6, whether you add all the numbers at once or just two at a time, the correct answer is 21. Thank you for learning about adding multiple addends with me today. Tomorrow, we'll practice more adding multiple addends. Tomorrow, we'll add 2 and even 3-digit multiple addends. I can't wait to do more math with you tomorrow, third grade.